Every CALIDUS GC needs to communicate with a personal computer. Every CALIDUS GC comes with two options. You can use an RS-232 serial port, but we're really pretty enamored with Ethernet. What we have here is an Ethernet crossover cable. I think these are RJ45 connectors. And to connect CALIDUS, simply take the connector just like you would on a telephone wire or any Ethernet connection and plug it into the port until it clicks. Make sure it's rigidly fast in place. I have a tag on this one. It says crossover cable. It's called crossover cable because we're going to connect not through a switch or a router. We're going to connect directly to the PC's Ethernet, and you need to have the in many computers the automatic detection is not in place as of yet. Newer computers have that feature, but to be sure, if you use a crossover cable with the proper connections on both ends, they'll connect directly through the Ethernet cable. If you're connecting to your laboratory network, just a simple Ethernet cable plugging into the plug on the wall and go through the appropriate setup, and you'll be able to talk to CALIDUS from anywhere in the world if you've got the username, password, and IP address. Okay, on the other end of the Ethernet cable, again, remember, since we're connecting directly to another Ethernet port on a device that has an IP address, we're using a crossover cable, and it's really just as simple as finding the right port, pushing it in place, hear it click, test it, and we're ready to start. CALIDUS is a very efficient instrument. Under the most demanding of circumstances, it uses less than 300 watts. In most applications, the average power consumption is somewhere between 200 and 250 watts of power. The power supply on this one for this particular application is about a 265 watt power supply, and it does need AC of one kind or another. And what we're going to do is simply plug in the power cord, and of course this end goes into the wall. We're going to run two GCs, the hydrogen and air gas station and the air compressor, and we're going to be using a typical 15 or 20 amp outlet from the wall, a single power strip, much different than the typical 3 kilowatts that most laboratory gas chromatographs require, and maybe even more for a process GC. So one of the things that makes CALIDUS kind of a neat tool to be in the hands of an analytical chemist is that it's a very powerful tool, and still 20 pounds, 22 pounds or so, less than 300 watts of power, gives you lots and lots of flexibility, not to mention the efficiency.
Now what we've done is we've set up two GCs for this conference, and you can see that actually it's pretty amazing that you can get these two GCs set up in a space this small. So we have a GC on each side with the control computer, and then hydrogen and zero air supplies there in the center. So if we're looking at this, one thing that we have to do, there are two cartridges that are here. One of them is a dryer for the air supply, and then the other one is where we will add water. You can have this work in two different ways. There is an automatic fill capability in this instrument, so once it's plugged into a source of deionized water, you can cap this off and leave it the way it is, or we can do it the way we're doing. We've got a gallon of distilled deionized water here, and you can add right into the top here. You have to add water, and then it will settle back down and fill up a tank. Once we're done, we can then just screw on and tighten this top, and we're ready to go. Close this off. There is a place right on the front where you can look and see what the fill level is, and it may be a little hard to see in the film, but we're right up about here. If you have this in an automatic mode, it will use this as the top fill line, and then when it gets down to this level, it automatically fills it back up. So it stays in this range. So we are safe working in this range. If you fill it all the way to the top, you can run for quite a while on about a gallon of water.